So last week we talked about the propagation of wave packet or curve. It can be described by given a wave function. Wave function AK. AK is a distribution around the reference point of K long. So we use this AK and consider this integration psi d equal to this potential I omega A T minus KC K. Okay. We use a given wave function. We use this wave function as the coefficient of the involved plane waves. We can imagine this as the limit of the summation of many plane waves. Okay. Each component is a plane wave. Then we sum over them appropriately. Then we finally get a wave packet. Or pulse. 这个所谓的脉冲啊，就叠完之后会是这样啊。After integration, finally we will get a pulse looks like this. That looks like this. Then now I try to find the approximate expression of the final result. To do this, we notice that the wave function is a function that has the form of a sharp peak. It has a width very narrow width. Okay, so most contribution comes from the region that very close to this reference point K0. So we can use this strategy. We can expand omega k in the form of a Taylor expansion. We can write omega k as omega of k naught plus the k the omega, taking the value at k naught minus k minus k naught plus 1/2 second derivative squared plus high order term. Okay. And suppose these high order terms are small enough. Okay, so small. So we do not need to take them into account if we just need to see the approximate result. Okay. So we can approximate omega k as omega k0 plus In the textbook, the author used a simplified notation to denote this, denote it as omega naught. Okay, and we know this one. This one is just nothing but the group velocity. Group velocity times k minus k naught. Okay. So now we can approximate the omega of k plus omega 0 plus dg times k minus k naught. Here dg is the group velocity. Okay. So once we use this expression and substitute it into the integration formula, we have psi z t equal to this. We can write ak as a k naught plus q. Here q is defined as k minus k naught. Okay. And exponential I. Now omega is omega 0 plus dg times q. Times t minus k naught plus q times t dq, because dq is equal to k. The reference k naught is a constant, not a variable. So dq is equal to dk. So using this result, we can write psi zt equal to, here we have omega 0 times t minus k 0 times t. This part has nothing to do with the integration. We can factor that out. Exponential I omega naught t minus k naught z times a k naught plus q, and then we have exponential I dgt minus z times q dq. Okay. So now this is function of q. The integration variable is q, and here is some coefficient. Okay. In fact, we can write this as here I can put one minus sign here and write this as z minus dgt q. The integration is over the range from minus infinity to positive infinity. Okay, so finally, although we do not, up to now we have not given you this form of this A. However, you know it's a very narrow distribution. And after integration, we will have only the information about K naught and Z minus B. Okay, so we can write the result as this one: exponential I omega naught T minus K naught Z times a function of Z minus B G T. Maybe it also depends on K naught. 就说我们现在这个积分，虽然我没有明确的基出它是一个什么东西，因为我们没有给 A 的形式。但是你知道积分完之后没有 Q 了嘛？因为 Q 已经用掉了 ，Q 在积分中已经用掉了啊，因为你上下限都是这个定值啊，跟这个 Q 是什么没有关系嘛？因为你在这个积分中，你把 Q 其实改名字，你还是同样的积分。比如说我叫它 Q prime， 是得到同样的积分，所以积分最后的结果跟 Q 没有关系。它会跟什么有关系？会跟 Z 减 BGT 有关，它可能也会跟 K 0有关 ，OK， 所以最后的结果我们就可以知道它是一个函数，是谁的函数呢？是 Z 减 BGT 的函数，啊，然后可能还跟 K 0有关 ，OK， 好，那所以我们就把最后的结果写成这样，好 ，so the final result is the function of Z minus G BGT. Maybe it also depends on K naught. Okay. So we call this is not electric field, this is so-called envelope function. This envelope function is just this integral. 所以这个最后的积分结果呢，会是一个 envelope。那通常 envelope function 呢，它会在一个范围内啊，就是所谓的波包啊，就是所谓的波包啊。所以我刚才会画成这个图。So this curve, or this curve is the so-called envelope function. 就是一个封包了啊，一个封包函数啊。好，就这样啊。那所以这个东西。最后结果是这个形式嘛，因为一个封包的形式，所以我们把这个东西叫波包啊，叫 wave packet or the pulse. So the final result, this object is called a wave packet or a pulse. 这是一个所谓的脉冲啊，脉冲或是。它跟原来那个平面波的概念就变得不一样啊！原来平面波是到处都是同样的振幅，然后是以固定的像速度在传播。那现在是把很多不同的平面波叠起来啊，这边每一个是不同的平面波，然后你把它叠起来之后，叠加自己在内部干涉完之后呢，它会干涉出一个什么东西？它会干涉出外面都没东西了。啊，然后只有这一包里面是建设性干涉，啊，所以就变成一包东西，这一包东西就叫做 wave packet 的破包，破包，啊，所以你看那个什么 医美的什么镭射脉冲光的脉冲啊，脉冲就会是这样东西啊，就这个是一包一包的啊。OK， 好，那这里提到的一个问题就是所谓的群度啊。So here you see that if you take the square of the absolute value of this psi function, you get this e z minus vgb square. So you see the z combined with t in this form. So this means that if z minus vgt is constant, then it keeps the same shape, okay? So if I differentiate this, I get dz over dt minus vg equal to 0, which means vg is equal to dz over dt. So this means that the center of this web packet moves with the velocity of vg. So the so-called group velocity is identified with the moving velocity of the center of the wave packet 啊，所以就是这个波包的中心点的移动速度，就是所谓的群速度啊，就是所谓的群速度啊。但这边有一点，这些说法有一点稍微简化了一点啊，因为我们刚刚的 approximation 其实有稍微简化了一些东西。好，我现在来解释简化了什么东西啊。So in this derivation, we have made some approximation. So we finally get the conclusion that the wave packet moves with the velocity equal to the so-called group velocity. However, if you try to apply this formula to a real dispersive material, then sometimes you encounter more complicated situation. For example, for most of the material, we have so-called loss. Loss means that the medium can absorb a part of the wave energy. 有时候这个介质会吸收一部分波包的能量啊，会变成热。那如果有 absorption 的时候啊，它代表什么意思呢？代表的是 omega 跟 k 之间的关系不是一个用实数能够直接表达，通常要用复数去表达啊，复数。那如果用复数去表达的时候，会出现什么情况呢？复数你就很难讲清楚 Vg 是什么啊，因为 Vg 是这个东西 d omega over dt。那如果今天你因为介质有吸收的关系呢，结果 k 变成负数，那什么叫做 omega 被负数的 k 为分？然后这得到负数的速度又是什么意思啊？所以就会变得讲不太清楚啊。所以通常我们这边如果要讲得很清楚的时候，你假设这个吸收够小，就可以忽略啊。So if I want to make things clear and simple, usually we assume that absorption or the loss is small enough 啊，是 low enough 啊，就是那个吸收或者是那个所谓的 loss 呢够小啊，那我们就直接用这个是没有问题啊。但是万一不是这个情况的时候啊，那就会有各种奇怪的事情出现啊，就会有各种奇怪的事情，比如说有些情况你可能看到说，波包好像可以超光速移动啊，但是呢，实际上那个都讲不太清楚啊，就是它会变成是有些 ambiguity 说不太清楚，但是你要弄出很炫的结果是有可能啊，比如说你让这个介质呢有 loss 或有 gain， 你就变出很多花样出来啊，比如说 某些情况看起来好像超光速啊，但是呢，你如果进一步追问之后，会发现哦，你有 gain 等于事先喂能量给他啊，那所以那个是事先安排好的，所以不算有因果关系啊。那总之就是说，这个东西如果牵扯到像速度，如果超光速是没有什么问题的啊，因为像速度本身它没有传递资讯，但群速度如果超光速的时候，就会有一个需要小心的地方，因为群速度携带的能量如果传递速度超过光速，就违反相对论啊。那你说违反相对论有什么了不起？那很了不起，因为我前2天还在看到那个脸书回顾里面10几年前啊。2011年时候，曾经有发生一个叫做 Oprah 事件。Oprah 是歌剧嘛 ？Oprah 是一个简写嘛？就有一个2011年的时候，有一个叫 Oprah 实验。Oprah 实验呢是这个欧洲的这个肾就是欧洲粒子核子研究中心，就专门在研究高能物理的，跟意大利的一个合作的，他们合作的这个实验的名称叫 Oprah， 他们去测量这个微重子的这个移动的速度有多快，就发现竟然超过光速一点点，好。然后呢，你即使只超过一点点，那都是一个很大的新闻，因为相对论告诉你最大的速度只能是光速。所以他们呢他们还是有第一波实验还是有认真去检查，觉得好像真的有超过，所以就announce出来说，这个微中子速度好像超过光速了啊。然后呢，这个就造成一个很大的新闻嘛。然后一开始很多人不相信嘛，然后但是呢。这个理论学家通常都不相信，但是一阵子之后信徒就会动摇，然后就开始瞎掰了啊，就开始你网络上还可以找得到 archive 上面有些 preprint 是解释为什么可以超光速，很多 paper 就审出来就因为这样可以超光速，因为那样可以超光速。结果呢，在后来其他组再继续下去一起实验检查结果都没有发现超光速的结果。他们自己在仔细检查之后，最后发现是他们光纤的连接有一点松，然后时间的计算差了一点点，然后把这考虑进去之后，没有超光速。然后结果呢，就有2个这个负责人就下台了啊，所以超光速是很严重的事情，可能会丢掉工作。好，那这个虽然相对论让人很不爽，就说你为什么光速不能够被超越，让我觉得很不爽，但是没办法，他的结论就是很被实验所支持啊，所以你要推翻相对论的话，你得有这个18般武艺，不是推翻它而已，因为它已经跟所有其他近代物理东西全部都连在一起啊，它是一个近代物理的理论的框架啊，它不是只有特定针对某个对象的理论，所以如果你得推翻相对论，你得同时推翻高能物理啊，推翻这个GPS 啊，那所以呢，这些是很难的啊，所以这个相对论告诉你说不会真正超过光速的话，那就真的不会超过光速啊。但是呢，如果你真的看到一个反例，那就是如果再仔细检查确实是对的，那就会是一个非常轰动的事情啊。所以这个 Oprah 事件最后落幕就是确认微中子确实没有超过光速。So finally they find that neutrino velocity does not exceed the speed of light in vacuum. OK. 好，那刚刚提到说这个射散介质可以玩很多花样啊，所以因为有吸收的关系啊，所以呢就有可能出现这个群速度超出光速情况啊。那但是如果没那样的话，那群速度怎么算？我们可以来举一个具体的例子啊。So suppose we consider this person medium, but the loss is small enough so we can ignore the loss. Then we can write K as omega over C times N. Here N is function of frequency。就是说，所谓的色散介质 dispersive medium 啊 ，dispersive medium。Dispersive medium means the refractive index is function of frequency. In fact, all materials are dispersive. However, if we can choose to operate everything, to arrange everything in a range of frequency that the dispersion is small enough, then we can approximate it as a non-dispersive medium 就是说，如果我能安排某一段频率的区间呢，这个折射率变得够小了，可以把它当成没有色散但是其实所有东西都有色散那一个色散的一个很具体的例子就是三棱镜就是我们可以用这个三角形的玻璃让光折两次，然后让这个白光被分解成七色的光，那代表的意思就是你不同颜色的光所对应到的折射率是不一样的。So we have this relation, K equal to omega of C times N. So how to calculate the Vg? We can do it like this. I differentiate K with respect to omega. I can do this. Then this is equal to 1 over C times N plus omega times the N over the omega. Okay? So this tells us that Vg is 1 over dk over the omega. 它是 d omega over dk， 我可以看成 d omega over dk 分子。And this is this. Okay. So you see that this is the group velocity, and what is phase velocity? Phase velocity is this one, and this is equal to C over N. This is phase velocity. This is group velocity. So you see this part is the set. Okay. Here in the numerator, this is a correction. Usually, the N over the omega times the omega is a positive. So Vg is smaller than Vp. Okay, and for common material, N is larger than 1. So we know that Vp is lower than the speed of light. And since the denominator is larger than this one, so we know that group velocity is even lower than the speed of light. However, the shape of the real part, of the refractive index usually has this shape. So if you, this is omega. If you calculate our result at this region or this region, then we have this quantity positive. Okay. However, if you calculate the result in this region, then you will get some trouble because here this is negative. So you have the chance to find a region that you find apparently group velocity larger than the speed of light, because if this quantity is negative, then this may become too small, so that you get a so-called group velocity larger than the speed of light. However, usually in this case, this region corresponds to high absorption region. Okay. High absorption. So it is not so easy to distinguish distortion caused by absorption or any mechanism caused the wave packet to move faster than the speed of light. 就是说，在这种情况下，如果吸收比较高的这个区域的时候，你很难去区分说，究竟是因为这个吸收造成波包变形，让你误判觉得它比较超光速，还是其他什么机制造成好像超光速的情况。所以通常我是避而不谈。但是那些如果是研究超光速为乐的人，他就故意去谈。OK， 好，那故意去谈的话呢，那这可能用 loss 啊，用 gain 啊，或什么会变出很多花样出啊，会变出一些花样出啊。好，那这个是关于 group velocity、phase velocity、波包等等啊。那还有一个东西刚刚没有谈到，就是如果在我们刚刚的 Taylor expansion 里面，如果在我们刚刚的 Taylor expansion 里面，把高阶项含进去会怎么样？ We know that omega k can be approximated can be Taylor expanded as omega k naught plus omega prime k naught k minus k naught plus 1 half double derivative k naught k minus k naught squared plus higher order term. Okay. In previous calculation, we ignore all the terms from the second order terms. Okay. However, if we keep the second order term, the part will be different. What result will be the difference is that the wave packet will distort or change its shape with time. Okay, and usually it becomes wider and wider. 就这个波包通常是越传越宽，越传越宽，会变宽。就通常是这样啊，就这个东西通常是正的啊。If the second derivative coefficient is positive, then the wave packet becomes wider and wider. This means that the wave packet get distorted during the propagation process. OK， 好，在这个传播的过程里面，这个波包的形状会产生一些变化，啊，它可能会逐渐变形，啊，逐渐变形。好，那大致上我们第一章就先讲到这，好，那我勾一点习题。好 ，So now I give you some homework.好，2个礼拜交，啊，就是这个两周后交啊。2 weeks。啊，你用我们通常给大家时间都很宽限的啊，就两周后交。好，那我大致上可能会出第1、第3。第4、第5章的作业，好，那更后面的我可能就不出了，好，我们虽然第7章会教，啊，第7章通常还是会教，然后我们期末考就考1、3、4、5、7，好，1、3、4、5、7，好，这几章，那我们现在就开始来进入到第3章，啊，第2章我略过，因为第2章主要是跟雷射有关，啊，跟我们的这个课的主轴比较没有那么大的关系。So now we move to chapter 3. Chapter 3 talks about polarization of light waves. Now, 我们在前面第1章有花了很多功夫跟大家讲说电磁波、电磁波啊，光是电磁波啊，所以我们需要用电磁场来描述它啊。那但是呢，在如果是固定一个频率的情况下，电磁场磁场的部分可以被电场所决定，所以我们最后还是通常我们就直接用电场来描述这个光啊。So in chapter 1, we have already introduced the idea that light is nothing but electromagnetic wave. For single frequency or monochromatic wave, the magnetic fields can be determined directly by the electric field. So usually we use the electric field of the light to represent the light property. Okay. So one thing in the description of light property, which is very important, is the so-called polarization. 我们其实已经先在第1章描述的主要是相位，就是那个 propagation 的部分啊，可能就 omega t 减 kz 的部分。但是呢，对于那个电场的方向那部分没有多琢磨。我们现在第3章的重点就在放在那个电场的方向啊。So in chapter 1, we have learned that a monochromatic plane wave can be written as this real A exponential I omega t minus k z. Okay. we introduce the so-called complex representation of phases to represent the field. The electric field, the real electric field, which we can measure, it can be written as the real part of a complex vector. The complex vector includes two parts. The first part is the amplitude, a vector amplitude. The vector amplitude itself can contain some arbitrary phases. And this amplitude times a phase vector is potential I omega t minus kz. This phase vector describes how the phase propagates. Now, we want to know if we take A to be an arbitrary complex vector written as ax exponential I delta x times x unit vector plus ay exponential I delta y unit vector. Okay. We want to know if we take the A vector to be an arbitrary constant vector with arbitrary phase vectors along the x and the y direction, then what kind of electric field we will obtain? Okay. 如果这个 A 是一个任意的复数向量它不只是某个实数向量去乘上一个 phase vector， 它是分别在每一个分量上都是复数就是在 x 分量上也是复数，然后在 y 分量上也是复数然后各自带有不同的相位的话那最后这个电场会长成什么样子？我想要知道这件事。然后呢，我们再根据最后这个弄出来的这个电场的形式呢，去加以分门别类去探讨所谓这个光的偏振问题This terminology is called 偏振，也有人叫极化偏振或极化但是有另外一个极化呢，不要跟这个极化混淆，就是我们之前第一章讲的叫做electric polarization那个 electric polarization 的意义跟它不一样The terminology electric polarization, the P vector in chapter 1. The P vector electric polarization. This quantity is nothing but the dipole density. Which means the total dipole per unit volume 就是每单位体积中的电偶极的总量是这个叫 electric polarization。但这个 polarization 呢 ，however this terminology this polarization means the vibration direction of the E field. E field, okay? They are not the same. 好，那现在我们就来看看这个东西究竟会得到什么。我们现在这个波呢是沿着 z 方向传播，但是它的振动平面是在 xy 平面So this wave propagate along the z direction. The vibrating plane of the E field is on the xy plane. That's why we write the A vector as the summation of two components the x component and the y component, because the polarization is on this xy plane. Okay. So now E of R T can be written as real A. I can write this x component AX times the exponential I omega t minus kz plus delta x, okay, plus y unit vector times ay times exponential I omega t minus kz plus delta y. Okay. So this means that Ex and Ey are this quantity. 现在这个 EX、Ey 呢，它本身都只跟 z 有关，跟 xy 无关啊，因为它的 propagation 的 direction 是 z。This is equal to Ax cosine omega t minus kz plus delta x. And this is equal to Ay cosine omega t minus kc plus delta y. Okay. So for this arbitrary A vector, A amplitude, we obtain the two components, the x component and the y component of the electric field as this one and this one. So now we want to discuss how does the tip of the E field revolve in time. 就这个电场它的这个尖端究竟在时间上变化之下它是怎么绕的啊 ？How does it revolve? So to discuss this problem, I try to simplify our notation. I denote this as alpha. I define alpha as omega t minus kz plus delta x. And I define delta as delta y minus delta x. Okay. So I can write the Ex and Ey as Ex can be written as Ax cosine alpha, and Ey can be written as Ay cosine alpha plus delta. So now I want to eliminate alpha. 我现在想要把这个跟时间空间有关这个 alpha 把它去掉，找出 Ex 跟 Ey 之间的关系。它会落在某个曲线上，所以它就会等于是它在演化的时候，电场就绕着那个曲线去找到那个东西。所以我们就是要找那个东西。这个我们下一堂课再来做。我们这边就先休息。 So now I want to derive the trajectory of the E vector, which means we need to eliminate alpha. So first I can do this. This is cosine alpha. And dy over ay is cosine alpha plus delta. Okay. So since we know that cosine alpha plus delta is equal to cosine alpha cosine delta minus sine alpha sine delta， 和差化积化和差，好 ，and we know that cosine square plus sine square equal to 1. Okay. So we can write this part as dy over ay, and here this is equal to dx over ax times cosine delta minus sine alpha sine delta. Although we do not know what is sine alpha, however, we know that sine squared plus cosine squared is 1. So we can express the square of sine alpha in terms of the square of cosine alpha, and we know cosine alpha can be identified as dx over ax. So this means that dy over ay minus dx over ax cosine delta square. This square is equal to sine square alpha sine square delta. However, sine square is equal to 1 minus cosine square. And we know what is cosine square. Okay. dy over ay minus dx over ax cosine delta square is equal to sine square delta times 1 minus dx over ax square. So we can expand both sides by dy square over ay square minus 2 dx over ax dy over ay cosine delta plus dx square over ax square cosine square delta is equal to sine square delta minus dx square over ax square times sine square delta. Okay. So we can move this term to the left hand side combined with the cosine square term. So finally we have this. 现在看到这个形式呢，大家应该知道这是一个圆锥曲线。So you can see that the final result described a so-called conic section 圆锥曲线。可是圆锥曲线有分3种一个抛物线，一个双曲线，一个椭圆你们觉得会是哪一种呢？ Which curve does this equation describe? Can you give me a guess? Is it ellipse, parabola, or hyperbola? Do you know? Ellipse. Why? You obtain your conclusion by calculation, by some mathematical knowledge. Okay. I can tell you we can judge the result using physical intuition because we know E squared is proportional to the energy density of a plane wave. Okay, and for a plane wave, the energy density is a finite quantity. Finite means that you cannot have the amplitude too large. Okay, because if you consider hyperbola or parabola, then this kind of curve extends to infinity. So it is possible to have a very large E. However, for plane wave, we have finite energy density, so it is not possible to have that kind of result. Okay. So according to our physical intuition, or you can judge the result by some mathematical knowledge, you can conclude that the final result, this curve is an ellipse. 好，所以就是我们可以判断出这个最后是描述的是一个椭圆。好，那既然描述的是一个椭圆呢，那我们最后的目标当然就是说，我希望找出这个椭圆的长轴跟短轴。So now we know the result is an ellipse. Now then our task is to find the major semi-axis and the minor semi-axis. 就是那个半长轴跟半短轴。然后第二件事就是我们想要知道这椭圆它的这个长轴指向什么方向。So now we want to know three things. We want to know three things. We want to know three things about this trajectory. First, we want to know A and B. Here, A is the semi-major axis, and B is the semi-minor axis. 就半长轴、半短轴。And we also need to know the orientation of these two axes. 我们想要知道说这个长轴指向什么方向。然后最后一件事，我们还想要知道是什么呢？因为在我们这个方程式里面呢，我们在前面的计算里面已经把阿尔法去掉了，可阿尔法本身是还有时间的。那如果把时间放回去的话，我想要知道的是，它究竟是这样绕呢，还是这样绕？So we also want to know the sense of revolution. Is it counterclockwise or it is clockwise? Three things. The two semi-axes we want to know the orientation of the axis and the sense of the revolution. We want to know these three things. First, let me show you how to derive the two axes, semi-axis. I can rewrite this as EX, EY, and EX, EY equal to 1. Okay? Here, this is 1 over AX squared sine squared delta. 1 over AY squared sine squared delta. Minus 1 over AX AY sine squared delta. And minus 1 over AX AY sine squared equal to 1。所以我们原来的这个方程式啊，这个方程式，我可以把sine平方 delta 除过来，然后改写成这样，那就行了。So let me denote the matrix between this and this as matrix M, and I can denote E. I can define E as EX, EY. Okay, and we know that E T is EX, EY. So this equation means that this equation can be written as ET and E equal to 1. Now, this is the original XY coordinate system. Now, if we rotate our coordinate system, I rotate the coordinate axis by angle phi to the new coordinate system, x prime, y prime. X prime, y prime. Then in this new coordinate system, E becomes E prime. E prime is described by EX prime, EY prime. Okay. Then we know that in this new coordinate system, the same equation can be written as x prime squared over a squared plus ey prime squared over b squared equal to 1. The standard form of an ellipse. And this can be written as Ex prime Ey prime times this 1 over a squared 1 over b squared ex prime ey prime. Okay. So how to rewrite this equation so that finally we have an equation of this form. Okay. We know that what is ex prime. Suppose this is an instantaneous E vector. Then what is Ex? Ex is the projection of this E vector on the X unit vector. And now if we project it on the X prime axis, we get Ex prime, Ey prime. Okay? So I can write this as the magnitude of E vector times cosine, say, I can write original Ex as the magnitude of E times, I denote this angle as theta. Theta is the angle between the E vector and the x-axis. So this is E cosine theta. And the Ey is E times sine theta. And what is Ex prime? Ex prime is cosine theta minus phi. Phi is the angle of the x prime axis with respect to the x-axis. And what is Ey prime? This. Okay. So this means that Ex prime is the magnitude of E times cosine theta cosine phi plus sine theta sine phi. However, E times cosine theta is Ex. And E times sine theta is Ey. Okay. Similarly, Ey prime. What is Ey prime? Ey prime is the magnitude of E vector times sine theta minus phi, which is equal to sine theta cosine phi minus cosine theta sine phi. This term, E cosine theta, is Ex, so we have minus Ex sine phi plus Ey cosine phi. Okay, so this means that Ex prime, Ey prime, Ex prime, Ey prime is related to Ex Ey, Ex Ey by this relation. here we have cosine phi, sine phi, minus sine phi, cosine phi. Okay. You may have already learned this relation by in your high school mathematics, which is called coordinate transformation. So if I denote this as E prime, and I denote this as S. Okay. S is a rotation matrix. Its parameter is phi. Phi is the rotation angle. Okay. Then I can write this as E prime is equal to S times E. Okay. So if you take the transpose, E prime transpose is equal to E transpose times S transpose. Okay. However, S transpose is nothing but the inverse of S, which is equal to minus phi. So we can also rewrite this as E can be written as S inverse times E prime. Okay? Because you can type the inverse of S matrix on the left hand side of these two parts. You get this? Okay. And which is equal to ST times E prime. Okay. So I can write this as ET is the transpose of E prime times S itself, because ST is S. Okay. Transpose twice becomes the original matrix. Okay. So now I can substitute the result into this equation. I can write this as ET is E prime E S times M times E is ST E prime S inverse E prime equal to 1. Okay. Because ST is S inverse. So now I can denote this as N so we have E prime T and E prime equal to 1. However, we know that N is nothing but this diagonal matrix. Here N, what is N? N is this matrix. This diagonal matrix. This diagonal matrix. Okay? So this means that we can do a similarity transformation. 那相似变换，相似变换其实在做的是什么事情？就是把矩阵从一种形式转成另外一种形式嘛。那其中有一种最特殊，就是转成对角化，就是对角化那个情况的话，就是你这个 S 呢，它就是一行一行是 eigenvector。OK， 好，那但是我们现在没有要特别去找 eigenvector， 我们用一个角度的方式去找到这个答案。We use the similarity transformation to change the original matrix M into a diagonal form. This form. So now we have this relation. So now we have this relation. N is equal to S M S inverse. However, we want to find not 1 over A squared, 1 over B squared. We want to find A squared, B squared. So we can do this by taking the inverse of the matrix N. The inverse of matrix N is equal to A squared, B squared. So if we calculate the inverse of the matrix, N inverse is the inverse. Okay, so we will reverse the order. S inverse give us S, M inverse in between, and S inverse. Okay, so finally we have this relation. Here S is the rotation matrix R phi equal to cosine phi, sine phi, minus sine phi, cosine phi. So we have this relation. Before we try to calculate the A squared, B squared, and the orientation of the axis, we need to calculate the inverse of M matrix. For 2 by 2 matrix of this form, suppose I have a 2 by 2 matrix like this, then there is a very simple formula can be applied to the 2 by 2 matrix to get its inverse. And inverse is equal to this. Okay. You exchange A and B, the diagonal part, and give minus sign to the off diagonal part, and divided by the determinant of this matrix, then you get the inverse of this matrix. Here, determinant M is AB minus BC. So now we apply this formula to calculate the inverse of M. First, what's AB minus BC? This is A, this is B. Okay. So this gives us AX squared, AY squared, sine to the fourth power, minus AX squared, AY squared. 抱歉，这边有个地方写错，这边是 cosine 的。Here, cosine 的。 So this is equal to cosine delta squared. Okay, fourth power. Cosine delta. Okay. So 1 minus cosine delta is equal to cosine delta squared is equal to sine delta squared. So this is equal to ax squared, ay squared, sine squared delta. Okay. So this means that M inverse is equal to ax squared, ay squared, sine squared delta minus D. I can write the result directly. The reverse, this times this. So we get ax squared. Okay. And if I times this, I get ay squared. And this times positive ax, ay cosine delta, ax, ay sine delta. No, cosine delta.好，那我们知道了这个之后呢，下一步就是把 n 平方，把 n inverse 找出来。So now n inverse is a squared 0, 0, b squared. This is equal to s times n inverse times S inverse. S inverse is just substitute the inverse, the minus phi replaced by okay. So first we see that we can obtain the orientation of the semi-major axis by using the relation, this one, the 1, 2 component, 1, 2 component. 1, 2 component is equal to 0. So how to get the 1, 2 component? 1, 2 component is obtained by, this is first row and the second column and the matrix in between. Okay, so this is equal to this cosine phi, sine phi times this. this is equal to 0. So this means that minus ax squared cosine phi sine phi cosine phi plus ax ay cosine delta cosine squared plus ay squared sine phi cosine phi minus ax ay cosine delta sine squared phi. This is equal to 0. Okay. And we can collect the result. Ay squared minus ax squared times sine phi cosine phi. Ay squared minus ax squared times. We know that 2 sine phi cosine phi is sine 2 phi. So we can write this as 1/2 sine 2 phi. And plus ax ay cosine delta times cosine squared minus sine squared. Cosine squared, we have ax ay cosine delta times cosine squared minus sine squared is nothing but cosine 2 phi. So finally, we find that one half times ax squared minus ay squared times sine 2 phi, okay, is equal to ax ay cosine delta times cosine 2 phi. Okay. So we see that tangent 2 phi, which is the ratio between sine 2 phi and cosine 2 phi, is 2 ax ay cosine delta over ax squared minus ay squared. So through this a bit lengthy calculation, we finally find that we can find the function of the orientation angle phi. Tangent 2 phi can be determined by ax, ay, and cosine delta. Delta is the phase angle between the two components, and ax, ay are the two amplitudes along the x and y direction in the original expression. Okay. So this is the first conclusion. We find this orientation phi. I have another task, which is to find a squared and b squared. You can just take the a component and one component, two component to find the result. Okay, you can take the one component. you use this first row here, first column, and the next and in between, then you can find the a squared. And if you use the second row, second column, and the m inverse in between, you find the b squared. Okay. The result of a squared and b squared are listed in the textbook as equation 3.2-7。我就不再把它写下来啊，就自己抄一下就可以抄下来。但是我这边我要讲一个后面会用到的东西啊。The expression of a squared and b squared are a little bit complex, so I do not cite them here. However, I want to mention one thing that according to this relation, n inverse is equal to, say, S F inverse S inverse. Okay. The two matrices N inverse and F inverse are related by the similarity transformation. Then linear algebra tells us that they have the same determinant. 经过这个所谓的相似变换得到的矩阵，它的行列式是一样的。这如果不记得的同学回去复习一下公数啊。那或者是你可以这样想，这有一个很简单的讲法啊，比如说你两个矩阵如果相乘顺序可以，不是说直接颠倒，说左乘可以乘，右乘也可以乘，不一定要一样啊。那你把它乘在一起取行列式的时候，跟它反过来取行列式会一样，会一样。那如果我把这个当成 A， 这个当成 B， 那我们就会得到什么？So determinant n inverse is determinant S minus S M inverse times S inverse, which is equal to determinant S inverse times S M inverse. However, S inverse times S is nothing but identity matrix, unit matrix. And unit matrix times any matrix does not change the matrix. So we get this. OK， 好，所以 n inverse 的行列式就跟 m inverse 行列式会一样。那这件事告诉我们什么呢？这件事告诉我们的是说，你看 n inverse 是这个矩阵嘛，那它的行列式就 a 平方乘以 b 平方，那会等于这个东西的行列式。好 ，so this means that this means that a squared times b squared is equal to ax squared, ay squared minus ax squared, ay squared cosine squared, which is equal to ax squared, ay squared times sine squared. Okay. So this means that a times b is equal to a squared, ax, ay times absolute value of sine delta. Okay. Here, do not forget to include this absolute value sign because sine delta might be negative. and a times b is positive。好，这边一定要保留这个绝对值符号啊。你开根号的时候要小心，它这个是有可能有sin delta可能有负号啊，所以要保留。那我们等一下会看到这个sin delta的正负号呢，会决定呢那个怎么绕的啊，究竟是逆时针绕还是顺时针绕啊？我还要再讲另外一件事，就是说。当这两个矩阵是相似矩阵的时候，除了行列式一样之外，连 trace 都会一样。好 ，Another conclusion about the similarity transformation is that if I take the trace of these two matrices, they will also be the same. Trace means sum over the diagonal elements. Okay, so this means that a squared plus b squared is equal to ax squared plus ay squared. Ax squared plus ay squared. Okay. These two conclusions are important, and I will use them later. 你如果想要仔细验证，就把课本上 a 平方 b 平方拿来加一加乘一乘你就会得到同样的结论但是那个处理方式很复杂，需要细节。但是我用线性代数的知识的话，不需要那些细节，我们就直接就知道这个结果。好，那我们现在跟暂停一下，我们下课。Okay, we now know that for an arbitrary amplitude and arbitrary phase difference of the two components, then the superposition result is an elliptic curve to describe the trajectory of the E vector. Okay. Now we want to know the so-called sense of revolution. This means that we want to know how does the E vector revolve. Is it clockwise or counterclockwise? To know this, we can learn something from the so-called Kepler's problem in mechanics, which means we can treat this as a planet revolve the sun 就好像一个行星在绕着太阳In that case, we know that we can calculate the so-called angular momentum to find the direction, the sense of revolution. If we treat this as the XY plane, if the angular momentum is positive, then this means that the revolution is counterclockwise. If the angular momentum is negative, it means that it revolves clockwise. If you try to figure out what is angular momentum is R cross P, which is equal to R cross mv. So the most important quantity is the R cross V. V is nothing but the R over dt. Okay, so we can just calculate the quantity like this to find a sense of revolution, which means that now we try to find E cross dE over dt, the Z component, E cross dE over dt. This quantity will tells us the result. Is it clockwise or counterclockwise rotation? And this is just equal to EX dy over dt minus EY dx over dt. And remember that EX is AX cosine omega t minus KC plus delta x. And EY is AY cosine omega t minus KC plus delta y. 我这边其实把它换成叫做 partial derivative 会好一点啊，因为呢，这个微分只为时间，没有在微空间。The differentiation has nothing to do with the space coordinate, so we replace this by partial derivative with respect to time. Okay, minus AY cosine omega t minus KC plus delta y partial t AX cosine omega t minus KC plus delta x. Okay. So this so the z component of E cross partial t partial E is equal to say the differentiation gives us minus omega and the change cosine into sine. Okay. So we have minus omega AX AY times cosine omega t minus KC plus delta x sine omega t minus KC plus delta y. And minus cosine plus 等一下那个 minus 有一个 minus 已经提到外面去了，就里面的 minus omega t minus KC plus delta y sine omega t minus KC plus delta x. Okay. So here we see that we have sine, cosine minus cosine, sine. Okay. In fact, this is just sine alpha plus delta cosine alpha. Minus cosine alpha plus delta sine alpha. Remember that alpha is omega t minus KC plus delta x. Okay. So this is just minus omega AX AY sine delta. So this means that if psi delta if minus psi delta if minus psi delta is positive, then we have counterclockwise revolution. Okay. If minus psi delta is negative, then we have clockwise revolution. We can also write this as, since minus psi delta is positive, means psi delta is negative. And this means psi delta is positive. Okay. So when psi delta is positive, we have clockwise rotation, and if psi delta is negative, we have counterclockwise rotation. This is the so-called sense of revolution. In fact, this sense of revolution corresponds to something called the angular momentum of photon. OK， 好，就是你如果去研究这个光子的这个自旋的话那它刚好会跟这个东西对齐。那这边我们就不太多着墨这部分但我们这边比较重要需要去注意到一些 special case Now we try to understand some special case of our general result. We discussed three kinds of polarization state. The most general one is the so-called elliptic polarization. And then we have linear depolarization, and we also have so-called circular polarization. Circular polarization. We have right-hand circular polarization, left-hand circular polarization. We call this counterclockwise, the right-hand circular polarization, and clockwise is left-hand circular polarization. If we consider the so-called circular polarization state. Okay. First, we consider the linear polarization. Linear polarization What is linear polarization? Linear polarization is this case delta equal to delta y minus delta x equal to m times pi. Here m is an integer. Usually we take only 0 and 1 because you cannot distinguish 0 and 2 就偶数，所有的偶数都相当于是0所有的基数都相当于1every even integer can be reduced to 0 and every odd integer can be reduced to 1 in the exponential the phase part. So we can just choose m from 0 and 1. So in this case, if we try to calculate the ratio between EX and EY, in this case, if I calculate EX over EY or EY over EX, EY over EX, then you see that we have this AY cosine alpha plus delta. Delta now is equal to m pi AX cosine alpha. Okay, cosine alpha plus m pi is just equal to this e to the power of m minus 1 to the power of m. So this is equal to this as AY over AX. Okay. So if m is equal to 0, then we have this kind of vibration. AX, AY. Okay. Then the electric field vibrates back and forth along a line. Okay. This is the case for m equal to 0. If m is equal to 1, then it becomes this situation. For m equal to 0, the E vector vibrates in the first and the third quadrant, 第一、第三象限. Therefore, m equal to 1, the vibration is in second and fourth quadrant, 第二与第四象限. So this is the so-called linear polarization. This is called linear polarization. 线性辩证线性辩证就是这个振动在一条线上For linear polarization, we mean that the electric field vibrates back and forth along a line, a single line. Okay. 好，那我们现在看所谓的 circular polarization. So now we see another spatial case. Circular polarization. For circular polarization, we mean that the delta y minus delta x is equal to plus or minus half pi. And AX equal to AY. Okay. So if we consider the special case that AX equal to AY and the difference between these two delta terms is equal to positive or negative half pi, then we have this one. So this means that suppose they are the same and I denote it as A, then this means EX is equal to A times cosine omega t minus kc plus delta x. Okay, and the Ey is the same 8 times cosine omega t minus kz plus delta x plus or minus 1/2 pi. Okay. We know that cosine theta plus half pi is equal to minus sine theta, and the cosine theta minus half pi is equal to cosine half pi minus theta, because cosine is an even function. So, and this is nothing but sine theta. Okay, so this is just equal to minus plus a sine omega t minus kc plus delta x. Okay, so if I denote this as a cosine theta, then this is a sine theta with positive or negative coefficient. Okay, so for the positive side, I can draw a circle of radius equal to 8. Then if we have the positive sign, then the trajectory is a circle and the revolution is counterclockwise. And if here we have a negative sign, then the trajectory is still a circle, but the revolution is clockwise. Okay. So for delta equal to half pi, we have clockwise, because now we have sine delta is equal to 1, which is positive. So we know it is clockwise revolution. And this is so-called left-hand circularly polarized line. Because why we say left-hand? Because usually we use the convention that we use the 4 fingers to around the thumb, and in this case, we use left hand. We use left hand to denote the sense of revolution. Okay. And for delta equal to minus half pi, we have when delta is equal to minus half pi, then we have sine delta equal to minus 1, which is negative. So we have counterclockwise revolution. Okay, this is right hand circularly polarized line. For general situation, general means arbitrary relation between EX and AX and AY, or arbitrary the phase difference delta, then we get elliptic correlation. Elliptic means this, okay, or this correlation. You can calculate the result. And now we need to introduce a quantity called electricity. Electricity. We can introduce a quantity called electricity. Electricity is defined as this one.课本它是直接给你一个正负号了啊，但是呢，这边我告诉你说，我们不用看这个正负号啊，或者我这边直接写成负的 sin 2，好这样子啊，所以我们可以定这个东西叫做 electricity 啊，那它包含了两个资讯，第一个资讯是这个椭圆有多扁。如果 A 跟 B 一样大的时候，那这个值就只是正负1，它就是一个圆啊。那如果是这个 B 比 A 小很多的话，那它就非常接近线片层，对不对？那或者是 A 比 B 小很多的话，它也非常接近线片层啊。那所以这个 electricity 可以代表说，你可以看这个椭圆的形状。这里还带一个正负号，这正负号用来表达那个 sense of revolution 啊，就是说我可以从这个正负号判断它究竟是逆时针绕还是顺时针绕啊。那这个东西叫做 electricity。那不要把它跟另外一个量混淆，另外一个量呢也用1去表示，那个东西叫做 eccentricity 啊。We have another quantity called eccentricity. Eccentricity means eccentricity is C over A. Here, C is square root of A squared minus B squared. OK， 好，那个叫做 eccentricity 啊。那 eccentricity 如果等于0的时候，啊 ，eccentricity 等于0的时候呢，就是圆，啊，那这个所以这两个是不一样的东西啊。eccentricity 叫做离心率啊，那我觉得这个应该叫椭率啊，椭率啊，就是它有多椭啊，就是这个有多扁或多长啊。OK。Do not confuse. They are different quantities. Okay. So now we move to the next topic. We need to use. We must have a method to represent the polarization state of wave. When we say polarization state, we usually ignore this part, omega t minus kz, this part. We ignore this part in our original definition of the E vector. We do not care about how it propagates in space, but focus our attention on the so-called polarization. 因为实际上我们写下一个 polarization 的时候，如果你在时间上去看的话，它其实也是变动的嘛，它要不然就是来回变动，要不然是这个绕来绕去啊。所以你如果把这也含进去，那个资讯量其实太多了啊。其实我们不用到这么多，我们只要知道它是什么形状。沿着哪个方向，然后哪一条线去 vibrate， 那这方面资讯其实就不是看这个，而是看那个 delta 跟那个 AX、AY 啊。So the most important information in the polarization of the wave is included in AX and AY and their phases. Okay, not this phase. This is time-dependent, space-dependent phase. We now care about the time-independent space-independent part of the phase. Okay, that part gives us the so-called polarization of the wave. So there are at least two ways to represent the polarization state. The first way to represent the polarization state is use a complex number we define as chi. Complex number representation of the polarization state. I think we denote it as chi. Chi is simply the ratio ay exponential I delta y to ax exponential I delta x. Okay, that's all. 好，就只有这样。那这个东西就写成 ay over ax exponential I delta. And sometimes we define the ratio ay over ax as tangent side exponential I delta. Okay. Why we call this tangent side? That is because we can relate ay to sine side and ax. We can treat ax as cosine side. Then the ratio between them become tangent side. 这个理由的话，那等一下遇到 Jones vector 的时候会更清楚啊。You will understand why we correspond ay to sine side and ax to cosine side later, because later we will introduce another representation of the polarization state called Jones vector representation. Okay. So, according to this representation, I give you some example. This is the chi plan. This is the real part of chi. And this axis represents the imaginary part of chi. Okay. So what is linear polarization along the, say, 45 degree? Okay. This polarization, we have ax equal to ay and the delta equal to 0. Okay? So this means that since ax equal to ay, we get tangent side equal to 1. And delta equal to 0, so this is also exponential 0 is 1. So this means chi equal to 1. Chi equal to 1 means this. Here is 1. So this point corresponds to this polarization. If we ask what is the polarization corresponding to the minus 1, then we can see that the result is this. Okay. Now, what is the polarization corresponding to minus I? Minus I, this point, minus I. Minus I means delta is equal to minus half I. And AX equal to AY. So this is the right-hand circularly polarization state. Okay, this is for this point, minus I. So how about positive I? Positive I corresponds to the left-hand circularly polarized line. Okay. For other points, in general, we have elliptic polarization. 好，就其他的就自己再去这个研究看看它是什么样的 polarization 它都会对应到一个特定的 polarization state. Okay, now we want to know if we know chi, how can we use it to calculate the orientation of the semi-axis of the ellipse and know the ratio between A and B, the so-called ellipticity and the sense of revolution. We want to know how to represent the quantity corresponding to the orientation angle of the ellipse and the ellipticity in terms of chi. Okay. So first, the orientation angle is simple to express in terms of chi. Okay. To do this, we know that tangent to phi, we know that tangent to phi is the orientation of the semi-major axis, is equal to 2 AX AY cosine delta. Okay. AX squared minus AY squared. Okay. We know that this formula in 3.2-8. So now, if we divide both the numerator and denominator by AX squared, we find AY over AX cosine delta. 1 minus AY squared over AX squared. Okay. How can we obtain this square? It's easy. If we take the absolute square of chi, how can we find this quantity? It's also very easy. We just take the real part of chi. Okay? So this can be written as real part chi over 1 minus chi absolute square. Okay? So this part is easy to derive. But how about how to calculate ellipticity or something directly related to ellipticity in terms of chi? This part you can do it like this. We know that E can be represented, can be expressed by this formula. This is ellipticity. And now, suppose we assume E. Suppose I define this as tangent theta. This theta is the abstract quantity. Is an abstract quantity. This theta has nothing to do with the theta we discovered before. Okay. Then we can show that sine 2 theta can be obtained directly by using the chi-related quantities. We know that sine 2 theta is equal to 2 sine theta cosine theta. Okay. And we can write the result as 2 sine theta cosine theta over cosine squared theta plus sine squared theta. Then we divide every term by cosine squared theta. You see, the result is 2 tangent theta over 1 plus tangent squared theta. You must be careful. Here is a plus sign, not a minus sign. If you have a minus sign, you get tangent to theta, not a sine to theta. Okay. And now we know this. Since we define E as tangent theta, so this is just 2E over 1 plus E squared. Although this quantity is not E, but it is directly related to E and has the same sign as E 就是说这个东西虽然不是 ellipticity 自己，但是呢，它跟这个 ellipticity 呢的符号是一样的，而且它可以直接可以去联系到这个 ellipticity 那这个东西换成这样之后呢，我们就可以用原来这个开去表示了。怎么表示呢？这样子说，So now sine 2 theta is equal to 2E over 1 plus E squared. But what is E? 2 sine delta over sine delta absolute value times B over A. And here we have 1 plus B squared over A squared. And this is just equal to 2 sine delta over absolute value of sine delta times AB A squared plus B squared. Remember that I have told you that A times B is equal to AX AY times the absolute value of sine delta. And A squared plus B squared is nothing but the sum of AX squared plus AY squared. Okay. So now we can rewrite this as minus 2 and AX AY times the absolute value of sine delta. And AX squared plus AY squared. And now you see that they cancel with each other. Okay? So this is minus 2 ax ay sine delta ax squared plus ay squared. And this is just minus ay over ax sine delta 1 plus ay squared over ax squared. And so finally we find that sine 2 theta is equal to minus 2 imaginary chi 1 plus chi absolute squared. Okay? And tangent to phi is 2 real chi over 1 minus chi absolute squared. Okay? So with chi, we can calculate the tangent to phi to find phi, and calculate the sine to theta to find theta and the tangent theta, and finally the ellipticity. 所以我们就可以在两种这个想要的资讯之中，这个做转换。好，那我们接下来就讲这一章的最后一节，叫 Jones vector representation。Now we discuss the so-called Jones vector. Representation. The so-called Jones vector representation is in fact even more simpler than the complex number representation. We just write the two components ax exponential I delta x, include their phase separately. Then this is the so-called Jones vector representation. Okay. This is directly related to the original definition of A vector. A vector is the ax exponential I delta x has the x unit vector plus ay exponential I delta y times y unit vector. Okay. So if I denote x unit vector as 1, 0, and the y unit vector as 0, 1, then the summation is nothing but this J vector, Jones vector. But usually, we do not care of the magnitude of the Jones vector. We usually normalize it to become a unit vector in the complex vector space. Okay. This means that we can write J as square root ax squared plus ay squared. And we can factor out the phase exponential I delta x. And then we have this ax over square root ax squared plus ay squared. Ay over square root ax squared plus ay squared. times the exponential ideal. You see, this square sums this square give us 1. So we can identify this part. We can define this part as cosine psi. And we can define this coefficient as sine psi. Okay. And the overall amplitude and the phase is not important. We can just ignore that. And finally, we can write this J as we can write J as this cosine psi exponential ideal of sine psi. Okay. Here, cosine psi is this. Sine psi is this.好，再讲1分钟。那为什么这个东西，这个 overall 的这个 amplitude 不重要呢？原因是这样啊，就是说以光子来讲，光是光子，光子是 boson。boson 的特性是什么？就是它其实可以大量的 boson 叠加在同一个状态之下。好，那我们现在问的是这个状态，不是有多少颗 photon。OK， 那个 total 的 amplitude 的这部分呢，它的绝对值应该会正于 photon 的总数，但是它并没有改变这个状态，而我们在乎的是这个状态，而不是那个光子的总数，所以这部分就不用写。这个好，所以这个部分就是所谓的 Jones vector 好。那这里面还有一些细节需要补充，我们今天时间不够，我们就等到下礼拜啊。So next week we continue this introduction.